Hello, in this video I'm going to show you how to use the surface weathering node in PixaFlux. The surface weathering node simulates water flowing across a surface and depositing sediment. It's perfect for generating realistic dirt maps that you can apply to your 3D models. Start by adding a scene, then load your 3D model. Add a surface node, and set the scene an object. Next, add a surface weathering node and connect it. Add a surface bake node and connect that as well. Finally, add a scene textures node. And set the debug shader to albedo. The simulate attribute runs the weathering simulation. You'll see three main output images: water level, water speed, and dirt. I'll set all attributes to 0 so we can walk through them clearly. Condensation adds a thin layer of water to the surface. Probability controls how likely each surface element is to receive water each step. Amount controls how much water is added. Rain also adds water. Rain end defines how long it rains. At 0, it never rains. At 10, it rains for 10 steps. Rain only falls on exposed surfaces, and slanted areas receive less water. The roof attribute determines how higher surfaces shield lower ones. At 0 degrees, the roof edge is sharp. Higher angles widen the roof effect. Samples smooths the rain-shadow transition. At 0, the roof effect is ignored. Larger values smooth the rain edge. Surfaces facing downward don't receive rain at all. With only condensation and rain, the water level increases but stays static. The flow attribute controls how water moves between neighboring surface elements. If greater than 0, water begins to run across the surface. Dripping controls how water falls from downward-facing areas onto surfaces below. For drying, the evaporation attributes define the probability and amount of water that evaporates each step. From step 10, the water stays at the same level. Now the water level is reduced and the surface dries. Dirt accumulation. With dirt set to 0, the surface stays clean. Increasing the dirt value makes the surface accumulate sediment based on the water level. I'll set all attributes to show the output controls. By default, each output image ranges from 0 to its highest value, so the highest value appears white. The set high attribute remaps the maximum value to a specific range for level, speed, dirt. Once you are happy with the results, save all output images to disk. In Blender, I have a scene with the sampler model using a dirty green plastic material. Add a shader network for the material. The clean green material, the dirty material, and the mask that controls how dirty the model is. The mask uses a small-scale noise texture for fine dirt particles, and a large-scale noise texture to define broader dirt regions. I remove the large noise texture and replace it with the water level image from the surface weathering simulation. Set the image color space to non-color, then connect it to the image mix node. Using an RGB curve, you can control how much dirt appears. Now let's apply the dirt output. And the speed output. And that's how to use the surface weathering node in PixaFlux. In a future video, I'll cover more advanced features like surface roughness and level input. If you have any questions or suggestions, feel free to leave a comment or join our Discord community. Thanks for watching. Don't forget to subscribe and follow us on Twitter, Blue Sky, and Instagram for more updates and tutorials.